Hi, I'm Bruce Bateman from Lydon, and today we want to talk about how AI affects the factory. As you know, Lydon has about 42 factories around the world, and for us, it's a very important factor. But how does AI shape a factory? I can't really talk about it in 15 minutes, so I'm just going to cover a couple of areas that is really interesting to us. You know, a smart factory is just more than just a factory floor. It's really about the people, the office back end, the delivery systems, the robotics and all. But today I'm just going to focus on one area of this called, one of the special AI areas. And everything you see in here has AI. So let's not talk about what all of that is. Lydon has been around for 45 years. And in our 45 years, we've been able to get our costs down. Our factory managers have spent the last 45 years taking every penny out of this. So what is our margin, our BOM, and our cost? We've got the costs down. We know how to do that. So if you're going to bring AI into our factory, well, it's really got to bring us some value. What value is that? It's got to go beyond our knowledge and our experience. It's got to show us things that we cannot humanly see. It's not just processing data. Showing us that a machine is going to wear out doesn't really help us a lot. It's got to show us a lot more. It's got to improve. It's got to do the predictions. It's got to do the learning that our humans cannot do in an amount of time. So what does a smart factory look like today? To me, there's sensors, you guys call it IoT, there are data collectors, there's a communication module. But the problem with this is there are 7 or 8 different protocols, and there are different kinds of transmission. And the data is really a structured data, and there's a lot of preparing of the data because each sensor is from a different manufacturer and they all have different formats. This is really, really frustrating and it takes forever to figure out. And then you got to figure out where to process the data. And you're going to get a lot of stories about edge, about factory edge, a private cloud, or internet cloud. All of that really has to do with really what's going on in the environment. And then what data analytics do you want? But this really, what you're seeing today is a one-way road. It's really about us collecting data and then showing data and giving you an alarm that, oh, this machine's going to die or, oh, that process is wrong. That's not really a smart factory. What is a smart factory is really two-way communication between the devices and us. A sensor that is actually embedded into the original equipment. Today we add on power monitors and all little rings or whatever into this. But what we really want is a two-way communication. That's a standard-based protocol. The data types can be structured or unstructured, being able to handle unstructured data, and standard formats where rules for missing data. For example, if one machine didn't report its data, is the whole report dead? Or do we have a way of actually adjusting for that? And then how do we put machine learning accelerators, chips at the edge? So one of the things we heavily believe in is that edge computing will include machine learning accelerator chips, and that will be in the edge. But data analytics needs a lot more than just the data of today. We need history, we need outside data, we need data from the machine supplier, we need data from our component supplier or from our raw materials. So when we do injection molding, the beads, where the beads plastic comes from, what all that data we need. How it was dried, how it was stored, all that information helps as we adjust the temperatures of our machines. So all of that needs to be in line and in one system. So we see systems with embedded sensors. So we see OEMs bringing embedded systems in and doing this in a real time. And it's got to be integrated into our shop floor management system so that how we manage this shop floor and this shop is all integrated. And it's all in a real-time fashion. But to do this correctly, there's more data out there. There's data from outside the shop floor. There's real-time data I'll talk about from the OEMs and the brands. We need some near real-time data from them as to how things are going. So when we make a product, how is it selling? Do we need to be prepared to make more, or do we need to be prepared to slow down? Do we need to prepare to change this? So we need to be much more aware and much more connected to our upstream system. There's also environmental data that affects how our machines work. Is it raining? Is it snowing? Is it flooding? All this kind of data we need to know. Employee data, who's here, who's available, who can work, where are those employees, location-based tracking. And then supplier data of the equipment and supplier data of our components. We need to have all of that into ourselves as a digital system. So the digital system is what we need. We need everything digitized coming in. Pricing adjustments. We might want to wait for something, or we might want to hurry something based upon pricing models. But this is an area that I think we really want to kind of focus on, which is how do we get connected better to our end customers, our OEMs, or our brand customers? How do we get closer to them? So they get data now. All of our customers are selling products today digitally, so they have a lot more data. And now our goal is to how do we get that data directly back to our factory so that from our OEM brand network to our factory, we can now begin to do prediction in our production. Try that again. Prediction in our production. So that we can now inform our supply chain what we need. We don't want to rush. We need to do just-in-time manufacturing, but we need to be predictive in our just-in-time manufacturing. And that's an area we really want to focus on. One of the big areas that I've been focusing on is called federated AI, and that's a little bit of a branch of AI. So everybody knows machine learning, deep learning, neural nets, natural language processing, computer vision and robotics. Those are the number one areas that you see today in the factory. But what is federated AI? So federated AI, if you look at how a machine does today, so the machine has an action, and then we use some kind of testing, either image processing or some kind of testing to say if the product is good or bad. So let's say we're using visual inspection, that gets a pattern. That pattern then looks at other sensors for testing, and we look at does it pass or fail. And if it passes or fails, that decision comes back, and we then we do another round, and we make it again. And then from there, we can start to see what works for our machine. We can say what the temperature can be, what the placement of a chip is. We can start to get our accuracies improved, and we can improve on our product. So this is one machine. That machine then creates an algorithm for itself that it knows from this particular process what it needs to do. But it takes a long time for that one machine to learn. So what we really want to do, and what we're focused on, is called federated AI learning. And that is all of the machines learn, but they come back to a central edge server, and that edge server then analyzes every machine. So all these machines are the same kind, and they bring in all that data together, and then they can send it back to each of the machines and say, we've noticed that this is better and this is bad. And then each machine will have the opportunity to make some kind of adjustment. Or not, because some machines may be running at a higher temperature, some may be running at a lower temperature. So these machines need to be smart. Now, why do you need all this? Because back in the old days, when I started in this business, injection molding, we had a factory manager that knew exactly how to do it. He had years, he knew the temperature, he would hold the plastic and go, okay, this is the temperature we need. There's too much water content in here. He had all that data with him. But now we're getting to an automated site, and we don't have those kind of people available anymore. So we need to figure out how we take that knowledge and transfer it into our AI system. So when I talk about that federated AI, I'm not talking about just one factory. So we have the same kind of machines in many of our 40 factories around the world. So we can take that data and bring it back to our edge. And then when I say edge here, I mean each factory. So edge in this case is a factory. I can bring that data back, I can have it analyzed, and then I can send that learning to the other factories. So maybe we've learned something from our machine, our process, our system, our complete system, that then helps our other factories. So AI in a factory really is a combination of a lot of things. Overall, you call it AI. I don't like that word. It's more machine learning or deep learning. And then you have the data science side, which is getting the data correctly. And then we have the machine learning side, and that is the federated learning that we're working on. And in a factory, you've got your input from our data. When I say big data, this is our environmental data. This is all data that come from everywhere else. And then you have to process that as in a machine learning format or in a deep learning format, depending on the algorithms you're looking for. And then that output is sent to the system, to the platform, and how that platform then interacts with the overall. So we may be able to tell our supplier that the plastics they sent us was not the right temperature or the right, can't melt at the right temperature. So all that data needs to be in real time going back and forth. And that's really the area that we want to focus on. So where's the future of smart manufacturing? AR, augmented reality in factories is coming. Glasses for you to look at a machine and tell you how to fix it. AR for process management, for how to look at what the whole process, where you should be next, where this device goes next, where this, you get a cart full of components, where do they go? Using virtual reality, we'll be launching our virtual reality process training in the next few days, showing how you can actually work on the machines using VR. Using machine learning and neural nets, embedding processors into edge is a big area we see. Today, visual inspection is the killer app for factories, but we see a lot of these robots that have the ability to have very fine touch and are dynamic self-learning robots that can be trained very quickly. Just-in-time, low production runs we see as a new trend that will happen, and that's going to require some rethinking in our factories. And lastly, additive manufacturing. We're very much into understanding how new materials, metals, aluminum, it can all be used for additive manufacturing, because we see the just-in-time decentralized production model, highly customized, coming. So these are the areas that kind of we see where the future of manufacturing is. And I hope today you got the opportunity to see something and understand how AI is just not a simple term. It's actually engulfs and collects all around the whole factory, and everything you do will have some kind of AI, and how you implement that will decide the success or failure of your project. Thanks.
Hello everyone, my name is James. I'm here representing i3D Microelectronics. First of all, I want to thank IDB for giving me the opportunity to come here and talk to you in this year's AI Day. And today my topic will be from capture to perception and understanding in terms of silicon-centric computer at the edge technology. So i3D is a microelectronic company that was founded in 2016. And we were focusing on computer vision for the past 6 years. This year, we were honored to receive investment from big investment firms such as ARM IoT Fund, as well as eTron, WI Hopper, and a few strategic partners. We strive to let everything see like human. Our vision is to empower everything, IoT, including IoT, consumer devices, industrial devices, a pair of eyes, as well as brains. So when we talk about AI, there are a lot of things we can think of, but I want to start by giving you a very simple example of your understanding of AI. If we look at this picture here, there's a boy and there's a guy. Both of them fall on a bicycle ride. What's the odds of people falling on a bicycle? You would say that kids has more odds in falling on a bicycle. Why is that? It's not because adults are smarter. It's not because kids are not as smart as the adults. It's because they're not trained. Their AI is not trained. That is why children are more tend to fall than adults. That is a very important concept when you talk about AI technology. To elaborate that, sensing is a very important element of AI. But if you look at today's technology, you talk about ADAS, you talk about autonomous drivings, you will see technology such as LiDAR, which capture and projects a very, very dense form of 3D information. But if you really think about human being, if you talk about humans, you don't really need those 3D sensors to help you drive. All you need to see is RGB images, and then your brain will help you process the 3D. How does that work? Basically, it's by your pair of eyes. So take reference of Tesla, who also install a pair of eyes at the very front of their autonomous vehicles. That helps their car to drive autonomously. But a lot of people say, do you really need two eyes? Can you do it with one eye? Yes, you can obviously do that. If you close one eye, this eye or that eye doesn't matter, you can still get a very good sense of the distance because your brain works the magic, okay? If you were to place these two bars on the same image, you will say that the representation of those bars will appear differently based on the given distance. So above, we're trying to elaborate the close relationship between vision as well as AI. So that gives us a lot of opportunities and money in terms of business. So we see a very, very big and vast blue ocean market coming to us. And I have to say, a lot of this was driven by COVID. There's a huge implementation of AI into the market during the epidemic situation, as well as this period of time. 3D data is driving these AI as the most essential part of the data retrieval. And we are i3D, we're trying to lay down those technology by our silicon-centric technology. So what are out there? First of all is robot. One of the most interesting and probably one of the hardest topics in the world. There are so many robots out there without us noticing, from your household home consumer robot to the commercialized cleaning robot, service robot you find in the airport, as well as these industrial robotic arms that's helping you doing the packaging, manufacturing, and everything. What do they need? Two things that are very important. One is data. For a robot to function well, they need a lot of data to compute, to help them capture, understand the world. Secondly is about efficiency. How do you get those data and then process them with a short given time and reacts based on those data? These are only achievable with the fundamentality of silicon technology in place. If we look at AI, we'll see a few stages. Here I lay it down to before. Let's look at AI chip 0.5 genera. This is when Intel, NVIDIA, and people like Xilinx lay down their grounds. Because at those times, a lot of the AIs are still being implemented on classical device. Sooner or later after that, about 2 years ago, we see people like Google implementing TPU, KAIS, as well as NVIDIA is doing something very different at a very fundamental level. This is where the trend and the application come to place. From now on, we see another wave of increment of AI entering our life, as well as the increment technologies. That part, we think the focus is on reconfiguration, as well as semi-general training, as well as inference model being done at the edge. Before we talk about that, let's talk about why we need depths. If you look at this video, it's very interesting. You see a very small glass being placed at a very big glass. From the appearance of it, you will say they're similar size. But if you take it away, wow, they're very different. On the other hand, if you see the cookie on the right-hand side, you will see that without 3D, it's very hard for you to recognize the third partition is missing a cookie. What we're doing is the stereo technology, two eyes technology. It's actually more than 3D. From one eye, you see an object. From the other eye, you actually see something that you couldn't see. So that is a distinctive advantage of stereo technology away from the other active 3D sensing technologies. So what's there? Like I said, adding data to an object or computer is never a bad thing. If you want to know somebody, it's better if you know where they live, what's his age, occupation, gender, and many things. That just helps computer and helps you to understand. Indirectly helps AI. So in the past few years, a lot of people are throwing money and their time into studying how to make these 3D data valuable. As you can see on the image shown on the slide, if you were place an object right in front of a camera with a stereo camera, you can capture the 3D image, which helps the AI to determine the shape of it. So it's no longer about the color, about the edge, but it's about three-dimensional information which human beings sees. Speaking of depths, what's the bottleneck? Why isn't 3D there yet? People's been talking about 3D for many, many years, but then up until now, we only see it being deployed on cell phones. Why is it not around yet? Let me tell you why. Because silicon is not there yet, because the 5G is not there yet, because the AI ability is not there yet, but now everything is in place. We're able to solve these bottlenecks by having more things compute at the edge. Do you know that 90% of the data that we get were generated in the past 2 years, and only a fraction of it is being analyzed? What does it mean? A lot of data is being captured, but they cannot be sent to the back to process. This results in a data waste, and that's what we don't want, because we invest our money, our infrastructure into collecting these data. That's why we need these chips. Okay? To have these chips, we can do a lot of different things. First, visually, we can see from 2Ds to 3Ds. We can start collecting audios, thermal, physicals, and a lot more. All are there to help the AI to process better and to help our lives better. A lot of people talk about tops and abilities of AI, but recently I figured that it became a race. People come out and they just shout for the higher tops. But what we need to understand at a semiconductor level or application level, what does each application requires in terms of computation intensity? Here I lay out a map as courtesy of ARM Holdings for all the sensory capture, all the sensory streams with the respective application and its required computation value. This is extremely important when you're thinking about deploying a device or implementing a new technology. So we talk about ourselves. The IoT market, as well as these AI and CPU computation market, has been largely driven by ARM. And a lot of it has been defined by the ARM CPU as well as the newly coming ARM NPU. In the past, all these NPUs and CPUs are being categorized mostly by applications. So if we see a red line being drawn, the lower end of the CPU, which is the M series of ARM, and the higher end of the ARM CPU core, A series, they set a very clear distinction in terms of applications. But in the past, when people are designing chips, usually you just pick one topic. I either do very high end or I do very low end. But at i3D, we do something very different. We're taking a new design approach to combine two different class of applications together onto the same chips. And fundamentally, we're solving one of the hardest problems, which is 3D sensing. How do we do that? This is a very interesting thing that we're working on. We call it the C+P project. So basically, we make these CPU and NPU into a smaller, different chips, what we call the C chip. C means computation. We have all the state-of-the-art ARM A-class CPU, as well as the N-class NPU, as well as the GPUs, being designed on top of the C chips. With these small chiplets, we're able to stack them on any of our chips, making our lower process chip more powerful than ever. Which means in the sooner-to-come long-tail consumer IoT market, we're able to offer customer chips at a lower cost because simply we're saving all those costs of designs to feed back to our customers. By doing that, you will see that I have these little icons right next to my alphabets. For C, they will be responsible for the very intensive computer vision as well as video streaming process. And at the P chip, we have a lower version of the CPUs as well as the NPU, which can process sensor fusion and also voice data. Combining them together, this will be a perfect processor for the future smart device as well as robotic. In i3D, we set our development in different blocks. In block 1, we work on the serious problems, algorithmic level and functional level, at depth perception, computer vision. At the second level, we work on integration heterogeneously with different forms of DRAM together with e-tron technology. At the third level, we work with ARM at deploying CPU, GPU, and NPU at a very different form factor as well as business model. And in the end, we integratively combine it into a sensor that allows a lot of long-tail market customers to pick up the system quickly and install, get a benefit, get their prototyping, and get their product out quickly. The result of that is a better development of a smart device and a smart robot. In our development roadmap, we start from stereo vision, going forward to applicational-driven subsystems. All of our subsystems are now designed into various robotic as well as smart sensing scenarios. Thirdly, we're working with on heterogeneous SIP SoC designs. And fourthly, obviously, leveraging our mother company's strengths in memory. We're working on the state-of-the-art near-memory computing for the future. Thank you very much.
Hi, everyone. Many thanks to join the AI Day section today. So also, we appreciate the invitation by IDB to invite ADLink to share how does the Edge AI can influence the different market to empower the different devices to get the more value added, to create some possibility from automation to autonomy. So let me introduce my company. So our ADLink is a 25 years old company with more than 400 R&D inside to develop the various technology among the transportation, automation, military, and medical. So not even mention ADLink is a public company. We did a very good performance in the stock-wise. So not only by following the standard from the different technology association, but also we sit in the technical community to contribute our observation, contribute our thought, and also our idea to create the new standards for the future demand. So right now, we are proud to share with you, ADLink is a member of a technical community of most of the association in the worldwide. And also, we understand what's the new trend by the open source. So we just contribute or donate our own technology, which is a middle way to create a time-deterministic connectivity. It's called a data distribution service. So we are happy to share with you now the robotic operation system and also the autonomous vehicle association already adapted DDS. Not only even mention our chairman got a very good co-strategic vision here. It's not only mentioning about the embedded system or the edge system, but also with the connectivity and with the decision-making among the SWAN, the group. So that's why there will be a key to not only provide the AI, IoT, or even the time-deterministic protocol and the SWAN protocol. So just to share with you is considering not only in the factory, but also in the city or the retail, transportation, or the retail market. So more and more edge devices need to be connected. And with the edge, the bus, the technology, the DDS, so they can communicate with each other in time deterministic. They can make the group decision effectively and efficiently. All right. Yeah, of course, the smart manufacturing is our specialty among the different markets. That's because we got a very, very strong foundation in automation and measurement and also IoT. So we can be proud to share with you now we understand how to get the smart factory succeed. First of all, still a field. You have to select the right field and also to invite the people who got the in deep the domain know-how. So they can share with you what's the right product, what's the right solution they are looking for, and what does the lost stuff that can help them and to enhance the operation efficiency, or even just to avoid any safety issue. So in the following page, I'm going to share with you some applicable case, the successful application cases. So you may learn from that part. So not only mentioning, so with the 4 years experience with mega manufacturing, so we learned something from them. The first thing is they are aiming at the 5 key applications and to enhance the factory, the CapEx and OpEx. The first thing is how to leverage the existing camera, or how to deploy the different the camera with the AI capability to enhance the operation efficiency and to ensure that everything can cooperate smoothly and safety. The second thing is, with the more and more the mobile device just being added into the smart factory the segment. So the factory owner considering about whether those like the MR, the autonomous mobile robot, can be operated instead of the human being, but provide the higher efficiency and also to reduce the cost significantly. The third and fourth themes, they're not the new matter here, but still a very important matter for the factory. Because without those the big data, no matter IoT, no matter cloud, or even like AI, they will be useless. So how to acquire the data from the field side smoothly without any pain, they will be very important things. And they also, the added link, the value bring to this market since 4 years ago. Okay? First things today, I could like to show you is how does the AI vision to empower the smart manufacturing. So with the AOI technology, which just been adapted for 20 years already, so you may understand people is used to use that kind of equipment or the devices to ensure the production quality. But now, the factory owner is considering where we can leverage some existing camera, like an IP camera, to enhance the operation efficiency and to avoid any tech safety the matter happen in the factory side, which covering your own employee or even a contractor. So, yep, I'm happy to share with you is even like for the production, the quality assurance, is not only to look at some high-tech the product, semiconductor, display the panel, or even like your phone, your cell phone. No. In some place in the worldwide, so people take this technology to inspect the quality of like the agriculture, the fruit, the chicken wing, and also is a tire. So right now, you can be life safety. They will be the one of the benefit powered by the AI vision. Not even mention is to look at some equipment or facility and ensure the whole human being can operate in a different field side, like a construction, the place, safety. So we do have some unique technology, and to just add this AI capability into the existing like the IP CAN or the NVR system, but without any impact. Okay, share with you is, you see, here's a video. The people just use the closed loop, the training on cloud and deploy on the AD-Link and edge devices to do the product inspection here, so he can sort whether this fruit just be tied to a whale or not. And with the no-code or the no-code environment which provided by the AD-Link, so the people can enjoy the AI capability in a short time. The following things is just sharing with you is how to leverage the AI vision to ensure the worker safety. So in this the video, you may see when you just hire the contractor from outside, then all responsibility will belong to factory itself when they just drive in. So where this truck parking in the right place, or where the contractor wear the suit for the suit, or where they follow the SOP to do the right things, they will be the matter. Okay, the next page, we just, to transform the existing factory to the smart manufacturing. So we do some demonstration. We do some beta side in our side itself. So here is like the high power test. So without the graph, the qualified graph, so we cannot allow the operator to do the test. Or, the high power, the power may impact the human being, the operator itself. So with the AI technology, so we can alert the measurement immediately. Okay, not even mentioned. So when people think about how does edge AI can influence them, can benefit them to bring some values, the first challenge is what could be the right topic to do. So not only even mentioning what's a powerful edge AI devices, what could be the very good communication protocol, the most important thing is we just showcase some successful story as a template. Then the people can adapt it, can do the very minor modification to turn it as yours. So for example here, we can take the edge AI vision to ensure the operator efficiency with a contractor from outside. And also, as mentioned earlier, so you can check where the chemical truck parking in the right place and the following procedure by the SOP. And also like the geofencing to avoid any safety matter happen. Last but not least is how to follow in the SOP to put the right things to finish the assembly. So there will be the very significant topic and the common interest among the 80% of the factories. Okay, just introduce with you, no-code or the low-code environment will be the trend for the next or the younger generation developer. So we have EVA, the Edge Vision Analytic software here. So also considering how to lower the barrier to encourage them to experience AI from now on. So we do have a very quick, fast POC kit. The second subject here is quite interesting, is autonomous mobile robotic. So as I mentioned earlier, so previously probably there are a bunch of the AGV already running on the factory, but with like the magnetic the tray or line, it will be very limited to do anything you want later to do. So with the new technology like the ROS, like the navigation the technology, so right now the people considering to migrate the existing AGV to the AMR system. So with this AMR system, you just need to drop what's this destination they are, and the AMR can finish the job by himself and to do the optical avoidance automatically. So not only even mention, so if you just try to spec in or put in a new MR system, so how to cooperate with the existing AGV system? No worry about it. So with the Swan autonomy particle, you'll be like the middleweight, they will be finished. So you can cooperate with the existing freight management, the new MR system, as well as the AGV systems. So thanks for the network. And also, like when people think about what does like the private 5G can benefit the factory itself, so he will be a very good example of cases, because how to measure, how to control, and how to manage the loss of the mobile devices in a tight determined environment with the very low latency. That will be the key technology I just mentioned in the beginning of my presentation. Okay, so that's a very, I would say, very cool or very good example here. Is you can consider with like the kind of AI vision, the technology, the gateway technology, as well as the Swan autonomy technology. Now you can let equipment to call Uber in the factory side. The Uber means MR, okay? So they will be operated automatically and the Swan and with a smart Swan group. So they can just execute the different task or the mission efficiently, okay? So without those the big partner, so we can knock down those very successful the story. So just to share with you, like the AUO right now is the biggest the shareholder, and not even mentioning they are the shareholder. They open the entire field side to help ADLink to evaluate any possibility. The second is when we mention about the private 5G, so without the supporting from the Foxconn group, so we cannot done it. Okay, so with like the FAROBA and more different entity who can build a beautiful and a various MR system, so you can find ADLink and with our partner to build your own MR system in your side. Thanks for your time to join today's section. Hopefully, I just give you some inspiration, in terms of the transformation of your vertical application. Thank you.
Hello everybody, I'm Tang Hong Po from Aegis Technology. Today I'm here to introduce a topic about using artificial intelligence for fingerprint security. This topic is very unique and new because the challenge we have in the fingerprint security system changes every year. This topic is also very practical since our company, Aegis Technology, is applying AI technology in our current fingerprint product. And I believe our peer or competitive companies are doing this as well. Before we jump into the fingerprint security topic, I would like to discuss one question first. The question is how to secure your device. Since we have so many different devices that can carry and store our private and personal information, usually, depending on the different functions, complexity, and the requirement of the devices, we can choose different security solutions. For example, we simply use a lock to protect the documents in our suitcase. We use a password to unlock our laptop. And for mobile devices, we have more choices like fingerprint recognition, Face ID, or even iris recognition. The mobile device is very personal and a unique device in our daily life. Since we use it a lot every day, it usually stores a lot of private and sensitive information of our daily life. Therefore, the security of mobile devices is very important to us. Currently, 3 major security solutions are provided by the cell phone makers. The first one is typing password. It's simple and straightforward. The second one is fingerprint recognition, which I will talk more about this today. And the third one is Face ID, which is the major security solution for iPhone series now. Here, I would like to look back a little bit about the evolution history of fingerprint recognition. The slide shows its market trend in its development history. In 2013, iPhone 5S used fingerprint sensor as its security solution, which is well known as Touch ID. And then the next year, 2014, like all the Android cell phone makers follow this path to add a fingerprint sensor on their Android phones. This is really a big step for fingerprint recognition, since the quantity of the cell phone is a lot. And then in 2017, iPhone 10 used Face ID, and the Samsung Galaxy S8 used iris recognition in their device. There was a voice about Face ID will replace fingerprint sensor very soon in the very near future. However, this didn't happen, since fingerprint sensor is very convenient to use, and a lot of people still prefer fingerprint recognition. Therefore, Android cell phone makers kept using fingerprint sensor on their Android devices. Recently, after 2019, more different types of fingerprint sensors are invented and produced on Android system. As you can see on the right-hand side of the slide, there are capacitive type, optical type, and ultrasonic type, and etc. Here I list 3 major fingerprint sensors that each technology have. And maybe you are familiar with these 3 if your Android phone has it. The first one is back capacitive fingerprint sensor, which is very common. The second type is the side capacitive fingerprint sensor, which become more and more popular recently. The third type is under-display optical fingerprint sensor solution, which is currently the major product line of our company. Here is the table that shows the demand and the application analysis of capacitive, optical, and ultrasonic fingerprint sensor. Each sensor type has its own advantage and disadvantage. Therefore, they can be used with different mobile devices according to the cost, performance, and the requirement. Now, let's talk about more on the fingerprint security. Since the fingerprint recognition is widely used on the mobile devices, the security level of the fingerprint system is very important. A lot of international organizations has built their security standard and the requirement for the fingerprint recognition. FIDO is one of it, and also a very important one. As you can see here, many international companies in the technology, finance, and the bank field already joined the FIDO Alliance to build the security standard together. We, Aegis Technology, is also a member of FIDO Alliance. Our fingerprint recognition solution must pass the test and achieve the security level of the standard so that it is considered to be safe enough to be used in the mobile devices. And not just FIDO, Google Android system has its own Google Android system has its own standard in testing methodology of fingerprint security. As I show here, Android standard lists a lot of different spoof materials which are commonly used to produce fake fingerprint. And the produced fake fingerprint can be used to attack or to spoof our fingerprint recognition system and try to pass our security check. Therefore, anti-spoofing is always a key function to prevent this kind of anti-spoofing attack. Here, we list some part of the materials in the Android standard, including gelatin glue, latex, Play-Doh, and the silicone. Also, fake fingerprint can be produced by black or red ink on the paper or on the film. On the right-hand side of the slide, you can see some people use color boards or Pantone to generate fake fingerprint. This slide shows the two-dimensional fake fingerprint that's produced by the color paper or ink. For example, if some people steal your fingerprint image and print it on the color paper, then they can use this fake fingerprint on the color paper to unlock your cell phone. This slide shows the 2.5-dimensional fake fingerprint. The fake fingerprint is generated by using different materials and molds. The right-hand side of the slide shows how it looks like after the finish of the production process. This slide shows the images of the real and the fake fingerprint looks like with our fingerprint sensor. Usually, fake fingerprint has better contrast on the fingerprint image and has very clear lines. But it's not always the case. Some real fingerprint can have high contrast too, and some fake fingerprint can be generated with a similar texture of real finger. As you can see inside the red frame of the image, the real and the fake fingerprint looks very similar to each other. Then this will be a difficult case to distinguish the real and the fake fingerprint. And that's why we need artificial intelligence to help us in the fingerprint security system. Since AI can analyze the picture with different angles from human beings, it can see some high and low level features of fingerprint images. And those high and low level features are difficult to be observed with human eyes. It will be helpful to apply AI technology to distinguish real and fake fingerprint in our fingerprint recognition system. Here is the architecture of the AI anti-spoofing system in the fingerprint recognition system. We merge AI technology into our current fingerprint system to generate multi-dimensional decision for anti-spoofing function. We can't just rely on one single feature for anti-spoofing. In fact, we extract a lot of different features of fingerprint together to judge if it is a fake fingerprint or it is not. Here, I visualize the features of our AI model can observe. The green one is a real finger, and the purple and the orange one are fake fingers. You can see that AI model can efficiently tell the differences of the real and the fake fingers, since their features are located at a different side of the feature map. With the help of the AI model, we can pass the test and achieve the standard of the fingerprint security. Okay, this is the last slide of my lectures. In summary, I present the evolution history of the fingerprint sensor system, and then I introduce the security standard and the issues of fingerprint recognition. In the end, I show the way that we use AI technology to help us in the anti-spoofing functions inside the fingerprint recognition system. The result of applying AI in the fingerprint recognition is very good, and it has been widely used now. Thank you for listening to the lecture today. Have a nice day.
Hello everyone, I'm Jake from AUO Digitech. I'm very happy to have this opportunity to share some applications of the roll-to-roll process in smart manufacturing. This presentation is divided into 5 parts, mainly to propose 2 solutions to challenge faced in the roll-to-roll manufacturing process. Before breaking into the topic, I would like to briefly introduce my company, AUO Digitech. AUO Digitech is wholly owned subsidiary of AUO. We provide an overall smart manufacturing solution. With years of smart manufacturing experience in the LCD industry, we provide a range of industry software
and big data analysis for the entire production process to assist our customer in achieve digital manufacturing transformation successfully. Currently, we have a total 4 global locations in Suzhou, Xiamen, Taiwan, and Singapore, and about 100 employees, 40% of whom are R&D, who are focusing on process optimization and creating powerful tools for the smart manufacturing field. AUO Digitech utilizes AUO's technology and experience of smart manufacturing to integrate human, machine, material, method, environments, and AI in the manufacturing process to provide customized digital transformation solutions, including software and hardware for our partners. Okay, let's get into the topic. The roll-to-roll process is highly efficient, low cost, and a continuous production method. Besides textile, printing, paper manufacturing, and other traditional industry, let's use the roll-to-roll production. Optical film, flexible display, FPCB, new energy battery materials, and other high-tech products also use the roll-to-roll process. The roll-to-roll process is a manufacturing trend of the electronic industry. However, no matter which product the roll-to-roll manufacturing technology is applied to, the following two problems always occur. First one is the production state cannot be known immediately. If continuous defect occurs during production, huge loss will be caused. The second one is equipment failure during continuous production. It will cause the production line to stop, resulting in the loss of productivity capacity. In order to resolving those two pain points of the roll-to-roll process, we have launched two relay solutions for quality control and equipment health management. First of all, for quality control, we have the roll-to-roll AOI solution. In the roll-to-roll AOI solution, there are three systems, namely online inspection system, smart classification system, and defect management aspect. Through those systems, we can find continuous defect immediately and discredit the loss of material cost. Cooperate with marking equipment, we can save the cost of human inspection, cooperate with the inspection process, and we can avoid leakage and reduce the R&A cost. The online inspection system is like the eyes of the roll-to-roll production. We use a variety of lighting methods to enhance different types of defects. For example, for surface defect, we use the reflection optical system to enhance it. For foreign object defect, such as particle and fiber, we use the transmission optical system for image enhancement. Our online inspection system has a friendly user interface, a powerful defect detection algorithm, and also is able to output quality inspection report immediately after the product is produced. The traditional roll-to-roll AOI has a higher requirements of parameter adjustment for users. In traditional method, users need to compare AOI detection result to sample repeatedly, adjust parameter, and test it. For rookie operators, it may take half months to adjust a set of parameters. However, it's just a one product parameter. That's why most of users consider the result of implementing AOI is not ideal. And the main reason is that parameters are not adjusted easily. Our roll-to-roll AOI provides a smart classification system, which transforms subjective judgment to human into an objective AI smart engine for classification. The smart classification can identify all important defects. In other words, with the smart classification system, it's possible for anyone to operate row-to-row AOI easily. Under the same classification accuracy standard, AI classification is about 15 times more efficiency than human classification. Row-to-row production usually goes through several manufacturing processes. It's critical to integrate defect information across manufacturing processes in row-to-row production. For this, we have designed the defect management expert. Through this system, defect information can be integrated across processes, and the real-time statistic information can be provided to assist engineers to improve production problems. In addition, defect management expert can estimate the production yield rate through location information of defects and the product models. And the engineer can evaluate the best cutting strategy according to the result of estimation. Through combined estimation information of production yield rate mentioned above and the product grade condition determined by the factory, defect management expert can also provide a way to automatically determine product grade and the subsequent inspection method. Compared with traditional methods, defect management expert is not only more accurate and efficiency, but also capable of avoid subjective judgments and the usual mistake of rookies. The above is the solution related to row-to-row AOI. The second part is for the equipment health management. We have abnormal warning system for row-to-row device. The row-to-row production is a continuous production process. Once the line starts, the equipment will operate continuously for 2 to 3 days. Therefore, equipment failure during production will cause a great loss of capacity. In order to avoid this problem, we have proposed abnormal warning system. This system is able to accurately warn 3 to 5 days ahead before the device becomes abnormal. Therefore, engineers can maintain the problematic device before production to ensure that equipment failure don't occur during the process. This picture shows the structure of the abnormal warning system. At the bottom layer, data is collected through various sensors installed in the production line, such as torque, tension, vibration, and temperature. The middle layer is a presentation of information. In factories, the data visualization is presented through the fab monitor. The top layer presents intelligent decision making. We use big data as the base to detect the area where the abnormal device is located through machine learning and deep learning. In short, we detect abnormal signal from a bunch of production-related big data through AI, and the abnormal signal represents the device need maintenance. Most of factories already own the function of data collection and data presentation, but the most important part, abnormal determination, is still analysis by human. The following picture shows the difference between traditional use, the fab monitor, and the intelligent early warning system. In the upper part is traditional method, monitor data from the various sensors through the fab monitor. It's difficult for engineers to do real-time monitor due to too many sensor points and complicated data. Therefore, usually investigate the cause of defect the device value with the fab monitor data. After all, it's difficult to achieve early warning. In the lower part, it shows the of use the device early warning system. We use AI to analyze big data to find key index and seek dynamic control method for different index. Not only monitor the change of the single factor, but also consider the interaction among the factors so we can achieve accuracy early warning of device abnormality. Regarding the impact of industry of introduce our system, we take customer A as an example. Customer A is a world top 5 polarizer manufacturer. There are about 20 or more devices valued in production each year before our system was introduced. In the first year of implementing this system, the number of device value was reduced to 6. Under engineers are not known well with the system and have not fully implemented the system maintenance mechanism for abnormalities immediately. In the second year, engineers fully implement abnormality warning and immediately maintain maintenance mechanism. The number of device value was reduced to 1. Besides quality control and equipment health management mentioned above, we are developing intelligent production scheduling, process parameter optimization, and energy-saving solution for the roll-to-roll process. This is the end of my presentation. Thank you for your precious time. If you have further questions or requirements, please feel free to contact me.
Hi, my name is Nolan, the tech manager of iAmbition. iAmbition is a new innovative company which started doing business from May 2020, and we reached the break-even point in half of year, which is incredible. In this year, our revenue has exceeded $350,000, and the EPS is now greater than 2.5. So what is our company's specialty? It's very simple. It's to make life safer and better. That's it. So let's take a look at which market is iAmbition's target. iAmbition aims to become a global solution developed with high-end techs, such as big data, AI, and IoT. With these technologies, we can fulfill digital transformation in tons of business fields to improve their security, management, and service quality. So there are lots of companies that we are working with. For example, Hitachi in Japan and leading in Taiwan, NVIDIA, Hello, etc. Here's our business model. There are 3 different ways: sales, lease, and OEM. Our main target is to do with B2B company. We have brought our goods to light in many ways. For example, recently, we have taken part of many exhibitions, such as Taipei's Smart City. And we have participated lots of innovation competition and award. But our goods also introduced by tons of news and business magazine in Taiwan. Let's move our attention to our core techs briefly. The first three techs have been mentioned before: big data, AI, and IoT. And the rest will be the application with parallel computation. So first of all, in big data analytics, we use data lake to centralize the data sending from IoT device or edges. Based on this technology, we can easily manage and expand our system. For example, device can be set in each department of a company. Even receiving the data from another city is available. Secondly, tons of deep learning models have been trained and being ready for the markets, such as face recognition, object detection, license plate recognition, heartbeat and breathing detection, and many, many more. Our algorithm is modular design, so with data lake, it's flexible to support edge and cloud computing. Moreover, to be smaller and faster, our models are support AI stick or chips, which gives a better performance in real time, such as Intel, NVIDIA, and Hello. There are many kinds of IoT devices we offered. For different cases, different types of unfit camera will be used, such as different shapes, 180-degree, LTE supported, Edge AI or thermal image camera. However, in some cases, due to privacy, it's not allowed to use unfit camera. Therefore, we provide time-of-flight camera and millimeter wave radar. Furthermore, air quality sensor is available as well. Lastly, we provide different customized parallel computing depends on the cases, such as public and private cloud service and decentralization computing. Based on that and the previous text, the user will be able to visualize information on an application platform, like website. I'll give some more explanation in the following parts. So let's take a look at how we resolve their pain point. In construct side, there are many dangerous places in there which is not easy to maintain or to control the employee to go into. And also the networking is difficult to set in the construct side. So we provide a system to monitor the places with danger places, that if someone go into the given area, the system will alarm to the manager that someone's just crossed over the bridge, crossed over the boundary. Here's another pain point that cannot be ignored, is in hospital. The rate of elderly is gradually increasing every year. However, that of healthcare workers is decreasing. Yet, it's hard to measure their physiological data firsthand without contact-type device. And any accidents like fall down cannot be discovered immediately as well. Therefore, we provide AI healthcare system. This system keeps the elderly and patients away from violation by using contactless devices, adopting the abnormal status for nurses who will be able to take care of them right away, right after. But how do we do that? In fact, we use TOF camera. Compared to other on-fit cameras, it's not privacy conscious, but also can work in the place without lighting. As you can see, there's no details that can be identified, the person in the pictures, but we focus on their actions for detection. It's normal to see a contact device on patients, which is used for detecting their physiological values, such as heartbeat and breathing. However, contactless devices, such as millimeter wave radar, provides a better experience for elderly and patients. Fire detection device is well used in the market. However, the lack of early warning for the beginning of fire is one of pain point. Therefore, if an emergency occurs, it's easy to fail to respond, and it is impossible to extinguish the fire in the first time. So we give a system that can give an earlier warning for the user that any kind of small fire or smoke happening in the area. So basically, in a small room that we only give one TOF camera and one radar sensor can do the things that we have mentioned before, such as fall detection and heartbeat and breathing detection. This is the world's first multifunctional integrated smart case management system for early detection and notification of abnormalities based on residents' behavior. So here's a demo that shows how we detect the fall action. When someone falls down in the room, the top right corner will shows a red button to alarm the nurse someone's falling in the room, so that she or he can go to that room to check what's happening immediately. Here's another demo that shows the radar sensor to detect our heartbeat or breathing. If someone is lying on the bed, there will be a person showing on the website. And you can also get the values on the screen. But if he leave the bed, then you will show the leaving bed red line on the website. So that's it. That's our demo videos. Thanks for listening.